We wish to evaluate this integral. We do know that we can split it up into two smaller integrals. Now, for the sake of time, I will do one of these, and then the viewer can just do the other half and then just add the two answers together. So suppose that I focus on this one here. So let's see, we have the integral of e to the x cosine x dx. And we are told, or we just know, that for this we should use integration by parts. Now recall, integration by parts, something like this would equal uv minus integral v du, where the setup is we have a u and a du, we have a v and a dv. Now what has to happen is you go to the original. There are two things that have to be split up. One of these plays the role of u, and the other one plays the role of dv. That's always how this works. Your two given functions, one goes here, one goes here. Now, which one goes where? Well, typically, the one that repeats over and over and over and over would go in for dv. But notice that both of these, they repeat. Now, when I say repeat, I mean derivatives. The derivative of e to the x is just e to the x over and over and over. The derivative of cosine would be negative sine, but then it's cosine, negative cosine, and so on and so forth, back and forth. So either of these could go in for either of these. So let me just put e to the x in for u. And cosine x goes in for dv, but the dx always goes with the dv part. Now, let's find these two parts. So if that's u, then du would be e to the x dx. And then if this is dv, then v would be just sine of x. You don't have to put a plus c at this point. Now, we have these parts, so we have to fill this out. And this is what this equals. So let's see. So we have all of this here equals, go u times v. So u and v, so go this times this. Minus integral. And then go v du. So it's v and then du. So we have sine x times e to the x dx, okay? So this is what we're trying to evaluate. It happens to equal this, which came to us from that. Now, as it turns out, this here, that is its own integration by parts. So we have to do this idea all over again, but just for this part here. So I could use the same letters. I could just use u's and v's all over again, but these roles would be dismissed and we'd have brand new assignments for u's and v's and dv's and du's and all that good stuff. So similar to the previous portion, u could be e to the x, and then dv could be sine to the x dx. And now du would be e to the x dx. And this would be negative cosine x. Very careful, right? Because the negative cosine. Now, let's rewrite all of this. Everything else stays the same up to now. So we have... Now, notice how I'm going to drop this subtraction symbol, and I am going to open up some parentheses, because this here is going to be broken up into smaller parts. And each of those smaller parts needs to receive this subtraction symbol. So now what replaces this? Well, another case of parts. So I need u times v. So this times this. And then minus integral v du. So it's v and then du. Okay. Now, let me just deal with some of these negatives. For instance, these two could essentially become positive. And then I can distribute this. I can put a 1 right there. And I can distribute that to that and to this here. So let's rewrite this. Now notice that these are actually like terms. So I am going to add this to this side here, because they're the same thing. It's just that it's negative here. So if I add it to that side, that'd be a 2. And it equals all of this business there. And now what can happen is we can divide by 2. And we're essentially done. Because what was the goal? The goal was to find the black box. But notice that is exactly what this says here. And it equals all of this. I factored out an e to the x and I put it above the 2 because we divided by 2. It was a GCF. This is what we have here. I'll just drop in a plus c. So notice that we found what we were looking for, but we sort of found it in a very circular fashion. We needed 2 setups of integration by parts. We added this to this side, and then we divided by 2. So that's a lot of times these problems work out in this way. Now, quick comment before I finish the video. Note that you have to go through and you have to find this part, right? You got to do this part, which is going to look just like this for the most part, and then add those 2 parts together. So this is half of the original, but this is the final answer for just the black box.